Hey guys, this is lesson 3.6 and we are learning about estimating quotients today. So before we start, I want to talk about this vocabulary word up here, which is really important. The word is compatible numbers, and it says they are numbers that are easy to divide mentally. It is important to understand compatible numbers today. For example, here are compatible numbers. 15 and 5, because 15 divided by 5 is 3. These numbers are not compatible, 15 and 4. Because 15 divided by 4 would have a remainder, not compatible. So here's two more compatible numbers. Let's say 24 and 6, because 24 can be divided by 6 easily without a remainder. So basically, today we're estimating quotients, and you're basically going to have some not nice looking numbers, and you want to change one number, the other number, or both numbers to make it a compatible number division problem. The main thing is you want to be able to do the division in your head. So let me show you example 1. Example 1 says estimate 11.75 divided by 3. So in this one, the first thing you always want to try is see if you can get away with only changing one number. And it's better to change the dividend, the first number, than it is the divisor. So I want to change 11.75 to something really close and easy that divides by 3. So the closest thing to 11.75 that divides by 3 is 12. Now 12 divided by 3 is 4. So 4 would be a good estimate because we didn't change the problem that much. Now in example 2, we have a real-world problem, and we'll show you how it is to estimate this one. Example 2 says the Jenkins family bought 5 tickets to a charity auction. So they bought 5 tickets. Okay, I'm going to circle that. The receipt shows the total cost of the tickets. Estimate the cost of each ticket. Justify your answer. So let's look at the receipt. 5 tickets cost $61.25. So what I want to do is basically to find the cost of each ticket, I would have to split the total cost 5 ways because there's 5 tickets. But remember, we are estimating the total cost. So I'm not even going to pay attention to the decimal numbers. They don't matter. I'm looking for the closest thing to $61 that divides by 5 without a remainder. So if I'm thinking, I know 5 goes into 60 and 5 goes into 65. They're both compatible. But you want the closest. So we are going to round this to 60 divided by 5. So think about it. This says the bill was about $60. And we're splitting it among the 5 tickets, and 60 divided by 5 is 12. So each ticket was about $12. All right, so now we're going to go down, and we're going to try A, B, and C. So I'm going to give you a choice here. If you are looking at A, B, and C, if you're like, I think I get this, I think I can do this, you can go through and pause the video, do A, B, and C, and then restart it when you're done to see if you were right. Now, if you're like, I'm not really sure about estimating quotients, then you could always do A, B, and C with me. Just pause the video when you need to. That's my point. All right, so decide if you're going to pause the video because I'm about to get started. So in problem A, we have to estimate each quotient, by the way. The directions say to estimate. So I'm going to keep this a nice 7 because I like 7s. And the closest thing to 49.3 is going to be 49. Because 49 divided by 7 is 7. Now here's one of the things, when you're showing your work, I do need you to show me what you're changing the numbers to. Don't just write 7 as your answer. All right, that's part of showing your work here. Now in B, I'm not going to change 25 because I think of dividing by 25s as like 25s are like quarters, 25 cents. So what I do want to change is the 98.1. Now, if you think of the numbers that 25 is compatible with, it's just counting by 25 numbers, 25, 50, 75, 100, 125, etc. So the closest thing to 98.1 would be 100. So I would do 100, oops, not 18. Let me erase that. Where is the undo? There we go. I would do 100 divided by 25 and get 4 as my estimate. See, I'd not have to do any work for that. That's the point of these. Now, in example 3, it says, suppose the Jenkins family decided to purchase 6 tickets for a total price of $64.50 using a discount. Estimate the total cost of each ticket, or estimate the cost of each ticket. So remember, it says estimate. Justify your answer. So if I were finding the exact answer, I would do $64.50 and I would divide it by 6. But remember, we want to estimate the cost of each ticket. So I'm trying to think, I'm not going to pay attention to the decimal, that doesn't matter, of the closest thing to 64 that divides by 6. And I know 6 times 10 is 60, and I know 6 times 11 is 66. So out of those two, the closest compatible number is 66. So you would round this to 66 divided by 6. And you would get, with a discount, that each ticket was about $11. All right. So hopefully you did well there. Have some more practice on the next page. So if you had a little trouble, we have more time to get good at it. So let's start with example 3. It says estimate 32 divided by 3.9. Now this is one where we're going to keep the 32 because 3.9 is really close to 4. And you could divide 32 by 4 because they're compatible, and you would get 8 as your estimate. All right. Now, example 4 says estimate 56 divided by 6.8. And this is another one where we would keep its 56 and change the 6.8 to 7 because 7 is really close to 6.8, and 56 and 7 are compatible. And 56 divided by 7 is 8. All right. Now, we're going to go down, and you have 2 problems to do below. You have D and E. Now, I'd like you to pause the video and try D and E. I'll tell you, you only have to change one number in each of those. So try D and E. When you're done, restart the video and see if you were right. Go. All right, let's see how you did. So first, in D, I'm going to change 9.16 to 9 because 54 divided by 9 is 6. 6 would be a good compatible number for D. Now in problem E, I'll show you 2 ways you could maybe do this one. And your answers are going to be close either way. Now if I'm doing this one, I would not change the 99 because I see 10.75 is really close to 11. And I know 99 divided by 11 is 9. Okay, that would be my easy way to estimate. But maybe you said, you know what? I'm going to change that 99 to 100. And I'm going to change 10.75 to 10. And 100 divided by 10 is 10. Now, either one of those are okay estimates because look at the answers. Look at the quotients. They're both really close to each other. So sometimes you might do it a little differently than someone else, but both of those would be okay in problem E. All right, on to the last page. We have a real-world example in number 5 and then problem F. Now, example 5 says, a Pacific leatherback turtle can have a mass of up to 704.4 kilograms. So that's basically how much it weighs. An olive ridley turtle can have a mass of up to 49.9 kilograms. Now it says, about how many times heavier is the Pacific leatherback turtle? Explain your reasoning. Now, did you see where it says about? That's your clue that this is an estimation problem. Now, when it says about how many times heavier, a lot of people think, oh, this is multiplication. But this is basically what you are answering. You are deciding that the olive ridley turtle, which is 49.9 pounds, if you multiply it by whatever number, we don't know, you would get the 704 pounds of the leatherback turtle, or kilograms, not pounds. So that's why it says about how many times heavier. We don't know that number. But that is actually a division problem. So you would, in reality, I'm going to draw a box here for some workspace. You would, in reality, solve that problem by doing 704.4 divided by 49.9. Now remember, it said about. I don't want to have to do this nasty decimal problem. That would be nasty. So I'm going to do some rounding. First off, this is really close to 50. And 50 is easy to divide by. Second, this is really close to 700. Now, you just have to do 700 divided by 50. And how could you do that mentally? Well, every 100 you get 250. So think, if you count by 50s, you have 50, 100, 150, 200. So basically, you'd have to count by 50 14 times to get to 700. So your answer would be 14 times heavier. All right? Now, we're going to have you try problem F. I want you to pause the video, try F all by yourself, restart it when you're done. Go. Okay, let's see how you did, guys. It says there are approximately 250.9 million cars in the United States. So that's in the USA. Now it says Spain has approximately 25.1 million cars. So that's in Spain. And Spain's a much smaller country than us. About how many times more cars does the US have than Spain? Explain why your answer is reasonable. We're not going to worry about explaining this. So here's what you would do. You would have to do the 250.9 million cars in the US and divide it by the 25.1 million cars in Spain. But remember, it says about. So I'm going to keep this one 25. And I'm going to keep this one 250. Because 25 goes into 250. Now watch this mental math. This is going to be pretty easy. If 25 divided by 25 is 1, just add that 0 and you're going to get 10. So the answer is the USA has about 10 times as many cars as Spain does. All right, so that was estimating division. Remember, change both numbers so they're compatible, and you want to be able to do the division in your head. If you have to do long division, then you're doing something wrong. All right, if you're absent, you probably also have some problems down here, so make sure you're looking at your absent sheet. Talk to you later, guys.